Far below the ocean's surface, where light ends and food is rare, some animals do the unthinkable. They grow huge. Not fast, not fierce, just big enough to survive. We assumed size only worked where food was abundant. In the deep sea, that assumption should collapse. Surprisingly, the giant squid is not alone down there. But why does life grow larger where survival seems impossible? The answer will take us through 5 animals. Each one survives differently, and the last one carries something we never expected to find. Darkness begins within the first few hundred meters. Temperature drops, pressure rises. Food does not arrive on a schedule. Sometimes it does not arrive at all. By surface world logic, large bodies should fail here. They require too much energy. They should starve, yet they persist, and not as predators. The first animal we'll meet hasn't eaten in 5 years. It's still alive. That contradiction will take time to explain. To understand it, we have to look at the animal that makes it impossible to ignore. Bathynomus giganteus. At 700 meters below the surface, the ocean floor is quiet in a way that feels permanent. There is no light, and the temperature hovers just above freezing. Food does not drift here daily. Sometimes it does not arrive for years. This is where Bathynomus giganteus lives, the giant isopod, the first example of deep-sea gigantism, and the simplest to understand. But how does an animal survive when the ocean forgets to feed it for years? A full-grown individual can reach about 50 centimeters in length and weigh close to 2 kilograms. That makes it one of the largest isopods on Earth, nearly 10 times larger than most shallow water relatives. But size here is not for intimidation. It is for storage. In the bathyal zone, meals arrive without warning. A dead fish, a fallen squid, sometimes a whale carcass, sinking for days before it finally settles. When that happens, giant isopods gather. They eat until their stomach fills almost 2/3 of their body cavity. Then they stop. And this is where expectation breaks. They wait. In captivity, this patience has been measured. At the Toba Aquarium in Japan, a giant isopod refused food for 1,869 consecutive days. More than 5 years. It did not starve. Its metabolism simply slowed, conserving energy at a rate smaller bodies cannot match. In effect, it becomes a walking reserve of energy. Size here means storage. The larger the body, the longer the weight it can endure. But storage is only one answer to the deep. The next animal found a different one. Mesonicoteuthis hamiltoni. At 1,000 meters below the Southern Ocean, movement costs too much. Chasing prey would burn more energy than the meal could replace. In this environment, speed is a mistake. This is where the colossal squid lives. Mesonicoteuthis hamiltoni, the heaviest invertebrate ever recorded. One adult, captured in 2007 and preserved at the National Museum of New Zealand, weighed 495 kilograms. And yet that mass is not muscle-built for pursuit. It is bulk-built for patience. Unlike its longer but lighter cousin, the giant squid, the colossal squid does not roam widely. Its dense body drifts, tissues rich with ammonia compounds that provide near-perfect neutral buoyancy. Slowly, sometimes barely moving at all. Studies suggest it consumes as little as 30 grams of food per day. For a body this large, that should be impossible. Its eyes hold the answer. Measuring up to 40 centimeters across, they are the largest eyes of any known animal. They do not search the dark for prey. They wait for flashes of bioluminescence. Often, that disturbance is caused by a sperm whale. And this is where expectation breaks again. We imagined the colossal squid as a relentless hunter locked in battle with whales. The data says otherwise. Beaks found in whale stomachs suggest it is usually the hunted, not the hunter. Its rotating hooks and massive beak are real, but they are tools for one chance, one grip, one meal that has to last. Cold water slows chemical reactions. Large bodies retain energy. Together, they allow time itself to become a survival strategy. The isopod stores. The colossal squid waits. But the next giant doesn't wait for food at all. It survives by becoming too large to kill, and it lives closer to the surface than either of them. Macrochera kempheri. At 200 meters beneath the waters of Sagami Bay, the seafloor does not reward haste. Food drifts slowly from above, sometimes after days, sometimes after weeks. This is where the Japanese spider crab thrives. Macrochera kempheri grows slowly. Like all crustaceans, it grows by molting. In cold water, each molt can be separated by years, sometimes decades. Over time, the body stretches outward, legs lengthen, joints extend. The result is not a bulky animal, it is a vast one. When fully grown, its leg span can reach nearly 4 meters. The body itself remains modest. Most of its size is distance, not power. The crab does not chase food. It waits. For decades, scientists assumed size implied dominance, but this animal has no venom, no crushing strike. Its defense is not aggression. Long legs keep vital organs away from danger. A predator bites a limb. The body stays out of reach. The larger it becomes, the harder it is to kill. Storage, patience, defense. 3 strategies, 3 giants. But the next one lives deeper than any of them, in a place we barely understand. Below this point lies the Hadal zone, the deepest environment on Earth. Alicella gigantea. The supergiant amphipod exists where few living things dare to go. The Hadal trenches. Depths exceeding 8,000 meters. Pressure surpassing 800 times that of the surface. Food arrives rarely, if at all. And yet this small crustacean grows to more than 34 centimeters, 17 to 34 times the size of its shallow water cousins. No model predicted this. Its body is stark white. Predators are almost non-existent. Large muscles and thick exoskeletons allow it to resist pressure that would crush most animals instantly. Scientists have documented individuals surviving months between meals. They are built to wait. Recent genomic studies reveal a genome nearly 11 times larger than a human's. Not as an explanation, but as a clue. Somewhere in that code may be the blueprint for surviving where nothing should. Then something unexpected appears. Persistent pollutants. DDT PCBS chlordane. 9 kilometers below the surface. Even here, the surface has reached them. These animals evolved for a world without us. That world no longer exists. But one giant survives without force, without pursuit, and almost without movement. Stygiomedusa gigantea. In the near-total darkness of the bathypelagic and abyssal zones, light exists only as faint glimmers of bioluminescence. Here drifts the giant phantom jelly, Stygiomedusa gigantea. Its bell stretches over 1 meter in diameter. Its oral arms extend up to 10 meters. It has no venom, no pursuit. It survives by interception. Plankton. Juvenile fish, whatever drifts close enough. It is viviparous, giving birth to live young. A strategy built for a world that does not rush. Like every giant we've seen, it evolved for patience, for stillness, for time. These animals didn't evolve to dominate their environment. They evolved to outlast it. For millions of years, that was enough. The deep sea moved slowly. Food was rare, but time was infinite. Size was the answer to a world without urgency. Now, 9 kilometers down, we've found our chemicals inside them. The deep sea still moves at their pace. We don't. And these giants, built for patience, shaped by stillness, have no strategy for what comes next.